Welcome. Really glad you're joining us again.
Great to be here.
Today, we're diving into a topic that's, well, it's literally us, ancient man. But, before you just picture a guy in a cave.
Right, with a club.
Exactly. We're going way, way further back than that. Our mission today really is to unpack the huge, epic story of where we actually come from. We're talking Earth's origins, how life even got started, and then this incredible, sometimes really surprising path of human evolution that leads right up to, well, you and me today.
It's a massive story.
It is. And for this deep dive, we've got some great sources, a bunch of really insightful educational videos. They lay things out very clearly, and also a pretty comprehensive document that adds some brilliant context and detail.
Yeah, good material to work with.
Definitely. So the goal is, as always, pull out the key stuff, those aha moments, and leave you feeling like you've really got a handle on it, maybe impress some people later.
Always a bonus.
Okay, so settle in. We're about to take a trip way, way back in time, further back than you might think, to really get where we come from.
Let's do it.
So when we talk about ancient man, the first thing that pops up is, okay, where do we even start this story? Do we kick off with the first human, or do we need to go back further?
That's the fundamental question, isn't it? And our sources are pretty clear. To understand us, you have to understand the stage first.
The planet itself.
Exactly. Earth, our home planet, it originated, get this, 4.6 billion years ago.
It's just, you can't even properly imagine that number.
You really can't. It's astronomical. So the first question has to be, how did our planet, this amazing place, how did it even come to be? What was that like?
Yeah, what was the process?
It's a great place to start because, like I said, you need the cradle first. So the scientific understanding, and this is well supported in our sources, is that Earth formed from something called a solar nebula.
Okay, solar nebula.
Yeah, just picture this immense swirling cloud. Just gas, dust, bits of rock, cosmic debris, basically the leftovers from when our sun formed billions of years back.
Right, just floating out there.
Well, not just floating. It was this chaotic, pretty violent process, all driven by one thing: gravity.
Gravity just pulling it all in.
Relentlessly. Over huge stretches of time, gravity pulled all these particles closer and closer. They started bumping into each other, sticking together.
Accretion, right.
Precisely. And as they collided and compacted, the pressure, the friction, it generated just incredible amounts of heat.
So early Earth was hot.
Unimaginably hot. Think of it like a molten blob, just a fiery ball of incandescent stuff, a cosmic forge, really.
Wow.
But then, very slowly, over millions and millions of years, as things kind of settled down and the surface radiated heat away, it started to cool. Started to solidify on the outside.
But not all the way through.
Not even close. And this is amazing. Even today, the very center of our planet, the core, is still as hot as the surface of the sun. We're talking around 6,000 degrees Celsius.
Still, after 4.6 billion years.
Still. And that heat isn't just sitting there. It's the engine, driving plate tectonics, volcanoes, earthquakes. The ground under your feet feels solid, but it's riding on this ancient furnace.
That's incredible.
It really is. And that same gravity, as things cooled, kept sorting things out. The heavier stuff, dense elements like iron and nickel, they sank towards the center.
Makes sense.
And the lighter materials, silicates and stuff, they floated outwards, forming the outer layers. It wasn't quite like oil and water, more like a planetary scale sorting based on density.
Creating layers.
Exactly, distinct layers. So you get the crust, that thin layer on the outside where we live, then the thick sort of viscous mantle underneath, then the liquid outer core, that's the bit generating our magnetic field, which is super important.
Protects us from solar radiation.
Absolutely vital, and right at the very heart, the incredibly hot but solid inner core.
So when we see lava from a volcano,
that's it. That's that primordial superheated stuff from the mantle, maybe even the outer core, making its way back up to the surface. It's a direct window into that deep, fiery history.
Wow.
So yeah, this whole formation story, this deep geology, it lays the absolute groundwork for everything that came next, including life. Including us.
Okay, that sets the stage perfectly. Earth is formed, it's got layers, it's cooling down, but still incredibly hot inside. A real powerhouse. But then, the next massive leap, right? Life. Where does life fit into this picture from billions of years ago? Because honestly, thinking about those early conditions, volcanic, maybe toxic atmosphere, radiation. It sounds so hostile.
It does, doesn't it?
Yeah, it's kind of surprising life could even get started, let alone the very first, simplest things. How did that spark happen in such a tough place?
Well, that apparent paradox is what makes the origin of life so fascinating, really.
Yeah.
And it shows just how tenacious existence can be. The sources point to the very first life forms appearing in the oceans, maybe other water bodies too, around 2.5 billion years ago.
2.5 billion. Still an immense time ago.
Oh, absolutely. And these weren't, complex creatures. They were incredibly simple. Single-celled things called prokaryote bacteria.
Tiny little things.
Microscopic, like little self-replicating chemical factories, basically.
Yeah.
Wrapped in a membrane, pulling energy from their environment, and they could handle conditions that would kill most life today environments, maybe rich in methane or sulfur. They were the pioneers, the absolute genesis of all life here.
Then they were in the water.
Exclusively in the water, yes. Now, if we jump forward quite a bit, but still way, way back in the grand scheme,
Okay.
we start seeing some really fascinating examples of early life becoming more diverse in the water. One creature the sources mentioned that really stood out to me was Opabenia.
Opabenia. Sounds interesting.
It is. Discovered in Canada in the Burgess Shale fossils. It lived about 542 million years ago. Picture this. Smallish creature, maybe 4 to 7 centimeters long.
Okay, not huge.
No, scurrying on the seabed. It had this weird flexible trunk thing, like a vacuum cleaner hose with a claw on the end, probably for grabbing food. It's weirder. It had 5 eyes.
5, not 2.
5. On little stalks on its head. And that really raises an important question, doesn't it? What does a 5-eyed creature tell us?
That evolution was trying out some strange stuff.
Exactly. It suggests this period of intense experimentation. Life was testing out all sorts of body plans, different sensory setups. The 2-eyed model we're so used to wasn't a given back then. Opabenia is just this vivid reminder of how incredibly diverse and frankly weird early life was in those ancient oceans. It was trial and error on a massive scale.
So the key point is life started in the water, period.
Absolutely fundamental.
Oh.
That's where the building blocks were, the stability, the energy sources. It all happened in the water first. And the progression, the sources lay this out clearly, went from those tiny bacteria, which, by the way, over millions of years, started pumping out oxygen through photosynthesis, changing the whole planet's atmosphere.
Wow, okay.
Then much later, the first plants evolved in the oceans. And then even later still, the first animals.
So bacteria, then plants, then animals, all in the water first.
That's the sequence. Life had to get a really strong foothold in the oceans, literally transform the planet's chemistry, before anything could even think about venturing onto land. It's all step by step, each stage building on the last.
It's incredible to think for billions of years, life was just an ocean thing, slowly changing the planet. So, okay, life's thriving in the water, simple stuff, then more complex things, even making oxygen. But then comes this. This really feels like a huge moment. Something decides to try dry land.
Yeah.
When did that massive shift happen? Because that seems like such a hurdle.
Yeah.
Gravity's different. You need to breathe air. You can dry out. How did life manage that?
It was definitely a monumental shift, you're right. And those challenges you mentioned, absolutely key. This wasn't an overnight thing, obviously. It took incredibly long time scales. Our sources point to the Silurian era. That's around 420 million years ago.
Okay, Silurian.
That's the period when the first species, having already evolved quite a bit in the water, started making that transition onto land.
So who were the first landgoers? Animals.
Here's a really critical point, and the sources emphasize this. Plants got there first.
Plants. Before animals.
Absolutely. The emergence of land plants, things like primitive mosses and ferns, that happened earlier, around 542 million years ago during the Paleozoic era.
Okay, so plants first. Why was that so important?
Well, think about it. If we connect this to the bigger picture, these early plants were foundational. They started to break down rock, create the first soils, hold moisture, and crucially, through photosynthesis, they kept pumping oxygen into the atmosphere.
Making the air more breathable.
Exactly. They basically transformed these barren, rocky continents into places where other life could potentially survive. They created the habitat, the food source. They literally paved the way for animals to follow. Without the plants, animals wouldn't have had a chance on land.
That makes so much sense. The groundwork had to be laid.
Precisely. So you have the first simple life in water, maybe 2.5 billion years ago. First land plants around 542 million years ago. But it took millions and millions more years for the first animals to actually make that move onto land.
So when did the first land animals show up, and what were they?
Around 420 million years ago. And they were arthropods. Think creatures like millipedes, maybe early scorpion-like things.
Things with exoskeletons.
Yeah, exactly. Robust enough, presumably, to handle not drying out, and the stronger pull of gravity. They were the pioneers. Then much later came amphibians, then reptiles, and so on.
It's amazing that sequence plants then animals makes total sense.
It just reminds you, again, every step in evolution builds on what came before. It opens up new possibilities, but only when the conditions are right, when the foundation is there. It's all interconnected, playing out over these mind-boggling timescales.
Okay, so the stage is set. Earth formed, life starts in water, plants move to land, then animals follow. Now we get to the real core of ancient man, right? How did we, Homo sapiens, fit into this? Where does our specific story begin?
Yes, exactly.
Because we've covered billions of years of groundwork, but our direct lineage. This feels this where it gets really personal and, yeah, really interesting. The sources say human evolution, our branch, kicked off maybe 6 to 7 million years ago.
That's the time frame, yes.
Yeah.
Still a huge amount of time, but definitely closer to home.
So what happened then, 6 or 7 million years ago?
That's when the crucial split happened. In the big evolutionary tree, the hominids, that's the group that includes us and our direct ancestors, branched off from the line that led to modern chimpanzees and bonobos. We shared a common ancestor before that point.
So that's the starting point of our specific journey.
That's the divergence, yeah. The initial split that set us on this unique path. And over those millions of years that followed, these early hominids started evolving traits that really set us apart.
What were the key things?
2 stand out, and they're deeply linked. First, developing an upright posture, bipedalism, walking consistently on 2 feet.
Walking upright. Seems simple, but I guess it was huge.
Absolutely revolutionary. Because what happens when you walk on 2 feet? Your hands are free.
Right, to carry things, make things.
Exactly. Carry food, carry infants, manipulate objects, and critically, eventually, to make and use tools. The second huge thing was the gradual but really profound development of larger, more complex brains.
Bigger brains, walking upright.
And what's fascinating, as our sources suggest, is how they feed into each other. Walking upright frees the hands for tool use, which requires more complex thought. Better tools and strategies mean better nutrition, which can support a bigger, more energy-hungry brain. That bigger brain then allows for even more complex behaviors, better tools, social cooperation.
It's like a positive feedback loop.
A powerful one. These 2 adaptations together really set the stage for everything that makes us human today. Language, culture, complex problem solving.
So walking was the first step, literally and figuratively.
You could say that, yeah. And eventually, out of this long, complex journey, Homo sapiens, that's us, modern humans, emerged.
When did we arrive on the scene?
Our species first appeared in Africa, the evidence strongly suggests, around 300,000 years ago.
300,000 years ago.
And what characterized us, what made Homo sapiens different, was this package deal. Highly advanced cognitive abilities, the capacity for complex symbolic language, and the development of rich cumulative culture passing knowledge down generations.
Language and culture, that seems key.
Absolutely game-changing. It gave us this incredible adaptive advantage, unprecedented cooperation, planning, teaching, learning. It allowed Homo sapiens not just to survive, but to thrive, and eventually spread out from Africa across the entire planet, adapting to almost every environment, reshaping it in the process too.
It's amazing that just starting to walk upright could lead to all this. You mentioned adapting to different environments, and one huge factor must have been the climate. The sources talk about the Great Ice Age. That sounds pretty major.
Oh, it was huge. A truly transformative period, and it overlaps significantly with key stages of human evolution. It definitely acted as a major force, a crucible, you could say.
So what exactly was the Great Ice Age? Just really cold?
Well, yes, extremely cold on a global scale, but it was more complex than just a constant deep freeze. Our sources define it as a period starting around 2.5 million years ago. Large parts of the northern continent's mountain ranges were covered by vast sheets of ice, glaciers kilometers thick sometimes.
Wow, for how long?
It wasn't continuous. That's the crucial part. The Great Ice Age was characterized by cycles. Think of it like maybe 4 long, intensely cold periods. The glacials where the ice expanded massively.
Okay.
But these were interspersed with 4 relatively shorter, warmer periods. The interglacials where the ice sheets retreated and the climate became much milder. More like today, sometimes even warmer.
So it went back and forth, cold, warm, cold, warm.
Exactly, oscillating between these extremes. And those warm periods, the interglacials, were incredibly important. Temperatures rose, ice melted, landscapes changed, and crucially, food often became abundant. You'd get lush grasslands, expanding forests, diverse animal populations thriving.
So the warm periods were times of plenty.
Relatively speaking, yes. Vital for animal survival and absolutely vital for our ancestors. These periods of resource abundance allowed hominid populations to grow, expand, maybe experiment a bit more. And this really raises an important question, doesn't it? How did these dramatic swings in climate act as this powerful selective pressure?
Pushing them to adapt, you mean?
Constantly, pushing them to adapt, innovate, or perish. It likely accelerated the whole evolutionary process.
So human evolution really kicked into high gear during the Ice Age.
That's right. The period from those early chimpanzee-like apes towards more recognizably human ancestors happened right alongside and arguably because of these Ice Age cycles. The challenges were immense, especially during the cold periods. Finding food, staying warm, developing new hunting strategies for different animals.
Yeah, you'd need to be smart, work together.
Absolutely. Yeah. Traits like increased intelligence, better problem solving, making more sophisticated tools, stronger social bonds and cooperation. These would have been hugely advantageous for surviving those demanding, fluctuating conditions. The Ice Age wasn't just a backdrop. It was actively shaping us, selecting for adaptability, driving the very developments that led to modern humans.
That's a really powerful idea, that the challenge actually spurred the change. Okay, so let's walk through that family tree then. Our sources lay out this progression, these different hominid species that mark key steps during this whole period. Who came first on our direct line after the split?
Okay, yeah, let's trace that lineage. The first really distinct hominid the sources highlight after that divergence is Australopithecus. They were around starting about 3.8 million years ago.
Australopithecus, like the famous Lucy fossil.
Exactly. Lucy was an Australopithecus afarensis. And their defining trait, the really big step, was bipedalism, walking upright consistently.
Right, freeing the hands.
That's the key implication. It freed the hands for carrying things, food, maybe infants, objects. And it opened the door for the very beginnings of tool use. Not really making tools yet, but using them. Picking up naturally shaped round stones, for instance, to crack open nuts or bones for marrow.
So using found objects as tools?
Yes, a crucial first step. Plus, walking upright might have helped them see over tall grass, maybe helped cool the body, and it's actually more energy efficient for covering long distances than walking on all fours, which was important as climates changed and food might have become more spread out.
Okay, so Australopithecus, walking upright, basic tool use. Who's next?
Next up, we have Homo habilis. The name literally means capable man or handyman. They appeared around 2.3 million years ago.
Handyman implies tool making.
Precisely. This is where we see a definite leap. Unlike Australopithecus, who mostly used found stones, Homo habilis started deliberately making stone tools. They take one stone, a core, and strike it with another, a hammerstone, to knock off sharp flakes, creating a cutting edge, a chopper.
That sounds more complex.
It is. This Oldowan technology, as it's called, shows planning. They had an idea in their head of the tool they wanted to make, and they knew how to shape the raw material. What's fascinating here is that cognitive jump, conceiving of shaping a tool, not just finding one. It implies foresight, understanding cause and effect with the stone.
And better tools meant?
Better access to food. They could butcher carcasses more easily, scrape meat off bones, maybe dig for roots more effectively. It gave them a real edge.
Okay, habilis, the tool maker.
Then comes Homo erectus. They show up around 1.8 million years ago, and were around for a very long time, maybe until as recently as 100,000 years ago in some places.
Yeah.
And they made a discovery that just changed everything.
What was that?
Fire. They were the first hominids we know of who learned to reliably use and control fire.
Fire. Wow, that must have been huge.
Transformative. Think about it. Cooking food makes it easier to digest, kills parasites, unlocks more nutrients. This likely had a massive impact on their health, energy levels, and probably even supported the growth of bigger brains, which need a lot of calories.
Right, cooking pre-digests the food, basically.
In a way, yes. Plus, warmth. It allowed them to survive in colder climates, move into new territories. It offered protection from predators at night, and it created a social focus, a hearth to gather around, extending the usable day.
So fire wasn't just for warmth, it changed their diet, their social life, where they could live?
Everything. If we connect this to the bigger picture, fire was a massive catalyst. It likely fueled significant brain growth and the physical changes we see in Homo erectus, like changes in the skull and jaw, possibly linked to eating softer, cooked food, a real pivotal moment.
Incredible. Okay, erectus and fire. Who follows them?
Then we get to Homo neanderthalensis, the Neanderthals. They lived mainly in Europe and Asia from maybe 600,000 years ago up until about 40,000 years ago?
Neanderthals. We hear a lot about them, often portrayed as primitive, but maybe that's not fair.
Increasingly, the evidence suggests that's really not fair at all. They were incredibly well adapted to their environments, often cold ones, physically very robust, big brains actually slightly larger on average than ours, though perhaps organized differently.
And the sources mention advanced behaviors.
Definitely. They were skilled hunters, taking down large game. They used sophisticated tools, the Mosterian toolkit. They controlled fire expertly. Our sources even mention them building shelters, sometimes using bones from huge animals like mammoths as part of the structure.
Building houses out of bones, that's impressive.
It shows real planning and construction skills. And they ate a varied diet, not just meat, but evidence suggests they cooked vegetables too, showing knowledge of plants. And this raises an important question. We often underestimate them, but Neanderthals were highly sophisticated for their time. There's evidence they cared for their sick and injured, buried their dead, maybe even had some form of symbolic expression or basic art. They weren't just brutish cavemen.
A much more complex picture.
Much more. A successful human lineage for hundreds of thousands of years.
Okay, so Neanderthals, and then finally us.
Finally, Homo sapiens, our species. As we said, emerged in Africa around 300,000 years ago. But the sources seem to focus on the period around 100,000 years ago as when we see the full package of modern human behavior really blossoming.
And what defines us according to the sources?
Well, our brain, obviously, developed for complex, abstract thought, allows us to innovate, invent new things at an incredible pace. But crucially, complex language. The ability to express intricate ideas, share knowledge precisely, coordinate large groups, build on past discoveries.
Language is key.
Absolutely fundamental. And alongside that, art. The sources mention dancing, music, painting, sculpture, ways to express feelings, build community, create meaning beyond just survival.
So thinking, language, art, the whole package.
The whole package. And this package allowed Homo sapiens to do something unprecedented, spread across the entire globe, out of Africa, adapting to vastly different environments.
And the sources mention different groups spreading out.
Yes. They note broad categorizations based on where populations spread and adapted over tens of thousands of years. They mention Caucasoids spreading into areas like North America, Russia, Greenland, Negroids primarily in Africa, Australoids in India and Australasia, and Mongoloids in East Asia, Japan, Korea, China.
Okay.
It's worth remembering, of course, that while these terms were used in the source material to describe large-scale population movements and resulting broad variations, modern science sees human diversity as much more complex, a spectrum, really. These are very broad labels for ancient migrations.
Right, important context. But the overall picture is this incredible journey.
From bipedal apes just figuring out how to use a stone, to us thinking, talking, creating, spread across the planet. It's an amazing chain of innovation and adaptation.
It really is. That journey through our ancestors is fascinating. But you mentioned it wasn't just physical changes or brain size. There was this parallel track of cultural evolution. Not just bigger brains, but how we lived, how we organized ourselves, how societies changed. The sources link this cultural change directly to the physical and brain changes, unfolding over maybe 2.5 million years. And you can see it in the tools, right?
Absolutely. The stone tools are like a physical record of cultural and cognitive evolution. You see them change over time, the shapes get more refined, more specialized, more efficient. It mirrors mankind's growing understanding, better planning, more skill. They aren't just rocks, they're like blueprints of ancient minds thinking and solving problems.
That's a great way to put it. So how do the sources break down this cultural evolution? Are there distinct stages?
Yes, they divide it into broad eras, mainly based on the dominant tool technologies and lifestyles. Each marks significant shifts in how humans lived and interacted with their world, driven by that mix of environment and intelligence.
Okay, so let's start at the beginning. The Paleolithic era, the Old Stone Age. This is the really long one, right? From maybe 2.5 million years ago all the way up to about 12,000 years ago. Covers almost all of human history.
Pretty much, yeah. The vast majority of our time as tool-using hominids falls into the Paleolithic.
So what was life like then, day to day?
Fundamentally, it was shaped by the hunt and the gather. People lived in small groups. The sources suggest maybe 20 to 30 members.
Small bands.
Yeah, likely mobile groups, nomadic. Constantly moving to follow animal herds, find seasonal plants, nuts, roots. Their entire existence was about extracting resources directly from the environment. Shelter was usually temporary caves, rock overhangs, maybe simple structures made of branches.
A tough life, constantly on the move.
Definitely demanding. But what's really fascinating, and the sources point this out, is even way back then, amidst the pure survival focus, you see hints of something more. Symbolic thought.
Like what?
Well, they mention the use of red ochre. It's a natural pigment. Evidence suggests it was used in burials for funeral rites.
Really? That implies ritual, beliefs about death.
It certainly implies something beyond the purely practical. A reverence for the dead, maybe early rituals, perhaps even ideas about an afterlife. It hints at a complex inner world. And then there's the art.
Cave paintings.
Cave paintings, yes. But also small figures carved from stone or bone, like those famous Venus figurines. These aren't just random scratches. They're deliberate artistic expressions. Communication, maybe storytelling, maybe spiritual significance. It shows an aesthetic sense, abstract thought.
Wow. Even that far back.
Even that far back. So imagine this world. Everything you need, you hunt or find. Constant movement. But alongside that, the beginnings of ritual, of art, of symbolic life. It's a stark contrast to now, but it shows incredible resilience, resourcefulness, and a deep connection to their world.
It really paints a picture. Okay, so that's the long Paleolithic, then comes the Mesolithic, the Middle Stone Age. The sources put this between roughly 20,000 and 18,000 years ago, a much shorter period. What changes here? Is it a sharp break or more gradual?
It's more of a transitional phase, really. A period of significant adaptation happening as the climate started to warm up after the peak of the last ice age, something we'll touch on more. People were still primarily hunting and gathering, still largely nomadic.
Still roaming for food.
Yes, but maybe with a more detailed knowledge of their local areas, the seasonal cycles. But we do see some interesting shifts. While they still use caves, they also started building more substantial, though still temporary, shelters. Houses made from things like leaves, sticks, maybe animal hides stretched over frames.
So investing a bit more in their campsites.
Seems like it, maybe staying in resource-rich spots a bit longer. And their tools changed too. A key development in the Mesolithic was the microlith.
The microlith.
Small stone.
Exactly. Small, precisely shaped stone flakes or blades. They could be fitted into handles made of wood or bone to create composite tools, things like spear points, arrowheads, maybe early sickles or knives. More complex, specialized tools.
More efficient, definitely. And art continued. They kept drawing pictures on rock surfaces, often showing animals, hunting scenes, human figures, still expressing themselves, maybe telling stories, recording events. So this raises an important question. While still nomadic, the better shelters, the specialized tools, it shows they're gaining more control over their environment, right?
Yeah, adapting more specifically.
A more developed lifestyle than the deep Paleolithic, really laying the groundwork, perfecting that sophisticated hunter-gatherer way of life, just before the next truly massive change. You can almost picture them, moving with the seasons, but really knowing their territory, starting to build slightly more homey bases, even if they moved on later.
That makes sense. Refining the existing model before a revolution. Okay, now for that revolution. The Neolithic era, the new Stone Age. Starting around 9,000 years ago, the sources say. This feels like the big one before modern times. The beginning of agriculture.
It is arguably the single most transformative shift in the entire human story. Yeah, it changed everything.
So why? Why then? After millions of years of hunting and gathering, what made people suddenly start farming and settling down? What kicked it all off?
The main catalyst, according to the sources and wider understanding, was climate change. Specifically, the end of the Great Ice Age, around 12,000 years ago.
The warming period afterwards.
Exactly. This ushered in the Holocene era, the warmer, wetter, and crucially more stable climate period we still live in today. The retreating ice sheets opened up new lands. Warmer temperatures and more reliable rainfall meant that wild plants, especially grasses like wild wheat and barley, started growing much more abundantly and predictably in certain regions.
So wild food got easier to find.
More reliable, definitely. In places like the Fertile Crescent in the Middle East, these wild grains became a major food source. And humans, who already knew plants intimately from millennia of gathering, started to experiment. Not just gathering, but actively helping the plants they liked. Maybe clearing weeds, saving seeds, planting them deliberately.
The beginnings of farming.
A gradual process, not a sudden invention, but yeah, cultivating grains. The sources list wheat, barley, paddy, which is rice, curachan, finger millet. And it happened independently in different parts of the world with local plants. Wheat earliest, maybe 9,000 BC in the Middle East. Maize much later in central Mexico, around 3,000 BC. Rice in China, maybe 7,000 BC, different places, different plants, same idea.
And animals, too. Didn't they start domesticating animals?
Absolutely. That was the other half of the revolution. Alongside cultivating plants, people started taming and managing animals. First, likely for a reliable source of meat on the hoof instead of having to hunt it, but then for other things, milk, eggs, wool, hides, and eventually for pulling plows or carrying loads, animal husbandry.
So farming plants and raising animals, a whole new food system.
A completely new system,
Okay.
providing a much more stable, predictable, and controllable food supply than ever before. A calorie revolution, really.
And the impact of that must have been huge.
Profound. Absolutely profound. And it rippled through every aspect of life. The most fundamental change, people started staying in one place. Sedentary life.
No more roaming.
Largely, no. If you've got fields to tend and animals to look after, you stay put. This led directly to permanent villages. Over time, some villages grew into larger towns and eventually the first cities. If we connect this to the bigger picture, this shift from nomad to settler totally reshaped human society. It's the foundation for everything that followed.
What kind of social changes happened?
Huge changes. With more food, populations could grow. And crucially, not everyone had to be directly involved in farming or herding anymore. You get food surpluses.
Meaning some people could do other things.
Exactly. Specialization of labor. You get craftspeople, potters, weavers, toolmakers. You get builders. You get leaders, organizers. Eventually, maybe priests. The sources mention the development of more formal worship, gods often linked to agriculture, fertility, good harvests, protection for the herds.
Society gets more complex.
Much more complex, and often more hierarchical. With land ownership, stored food, maybe trade goods, you start seeing differences in wealth, the beginnings of rich-poor divisions. Urban living brought new challenges to sanitation, disease, but also new opportunities for cooperation, defense, large-scale projects.
And technology must have changed, too.
Definitely. Living in one place spurred innovations, pottery for storing grain and liquids, weaving for clothes and textiles, better building techniques, and eventually the discovery and use of metals, first copper, then bronze, then iron. Metal tools were much more durable and efficient for farming, building, and unfortunately warfare too.
So the Neolithic wasn't just about farming, it was the start of, well, civilization as we know it.
Pretty much. All the complexities, the innovations, the social structures, the inequalities, the challenges we still grapple with today, their roots are right there.
Yeah.
And that transition to agriculture during the Neolithic, it really was the point where human history took a sharp turn onto the path we're still on.
Wow. What an incredible journey we've covered today. Seriously, a deep dive. From that swirling cloud of dust 4.6 billion years ago.
Billions, yeah.
Through the first spark of life in the oceans, the huge step onto land, then this amazing parade of our ancestors, Australopithecus walking tall, Homo habilis making tools, Homo erectus mastering fire, the sophisticated Neanderthals, and then us, Homo sapiens, thinking and creating. And finally, that massive shift. From moving with the herds to planting seeds and building villages, from hunter-gatherer to farmer. It's just an unbelievable story of change and adaptation.
It really puts things in perspective, doesn't
It absolutely does. Understanding this incredibly long history, it gives so much context for who we are now. It shows how far we've come, the challenges overcome, and how deeply connected we are to that ancient past. It's humbling, but also kind of inspiring.
It is. And maybe, it leaves us with a final thought, a question for you, the listener, to mull over. Considering these immense timescales we've discussed, billions of years, and all the intense environmental pressures our ancestors faced, fiery planets, global ice ages, the huge upheaval of starting agriculture. What does this deep history tell us about humanity's fundamental capacity for adaptation, for innovation, for solving problems together? And maybe, how might that inherent capacity, forged over millions of years, shape our future as we face the new, equally profound challenges of our own time?
That's a great question, a really powerful thought to end on. Our resilience, our ingenuity, it's literally baked into our origins. Well, thank you for joining us on this amazing deep dive into ancient man.
My pleasure.
We hope you feel a bit more informed, maybe a little more connected to that incredibly deep history we all share, and definitely more curious. Until next time, keep that curiosity alive.